So hello guys, welcome to my channel. Today we are going to discuss a special theorem related with polynomials. So to start, we will take a look at the general definition of a polynomial. So a general polynomial is defined like this, where ai's are the real coefficients like this, and the an does not equal to 0. This is the general definition of a polynomial. So now we want to take a special value which we will name as alpha which equals coefficient So we will take the coefficient of x and divide it by the constant term, and we will negate it by multiplying a negative sign. So this will equal to, with this general definition, the coefficient of x will be a1, and the constant term, when I refer as the constant term of a polynomial, I refer as this as a0, and the negative stays the same. So now we will make some observations. So first of all, we will take a look at a general first degree polynomial. Here a is just a constant. So now here we will check what is the value of alpha in this case. So alpha would be equal to the coefficient of x. What is the coefficient of x here? 1. And what is the constant term? Negative a, and the negative will stay the same. So here we will be left with 1 over a. Now we take a look at a general case of second degree polynomial. Now this is the general case of a second degree polynomial, and this polynomial can be factored like this. So this is the general case. Now we will check what is the value of alpha in this case. We will put the negative sign as it is. Now what is the coefficient of x here? It is this negative a plus b, and we will divide it by the constant term here, that is ab. So this will simplify to 1 over a plus 1 over b. So this is it. Now we will take a look at the general case of a third degree polynomial. Now we will take 3 and if you expand this, you will get this will be x, right? So this will be like this. So now in this case we would check the value of alpha. Here alpha is this. First of all we will put the negative as same and the coefficient of x, which is this, and divided by the constant term, which is negative ABC, and this all will simplify to so this is it. Now we have checked 3 cases of polynomial. So far what we have seen here. So at first glance you will not easily get the pattern, but if you see, first we get 1 over a, then we get the reciprocal of a and b, and then abc reciprocal. So 1 over a, and here what is a? A is the root of this polynomial. Specifically, if we put a here, the polynomial would be 0. That means that a is the root of a polynomial. And same here in this second degree polynomial, a and b are the roots of this polynomial, and in this case a, b and c are the roots of this third degree polynomial. So basically what alpha is giving out is that it is giving out the sum of the reciprocals of the root. Here only a is the root, so 1 over a. Here there are 2 roots, so 1 over a plus 1 over b. Here there are 3 roots, 1 over a plus 1 over b plus 1 over c. So this is the observation we have get, and this will give you the intuition of what the theorem exactly says. So I will rub the board and we will get to it. So far we have reached this point and we have written the theorem. We have discussed that in a polynomial the negative of the coefficient of x divided by the constant term gives you the sum of the reciprocals of the root. Now for example, we have taken this cubic polynomial. This cubic polynomial factorizes like this: x minus 1 times x plus 2 times x minus 3. Now here the roots are 1, minus 2 and 3. So according to the theorem, the negative of the coefficient of x divided by the constant term gives you the sum of the reciprocal of roots. So this thing must equal to 1 over 1 plus 1 over minus 2 plus 1 over 3, and this thing simplifies to be 5 over 6, and the right hand side simplifies to be 1 minus half plus 3, and 1 minus half is exactly half, so this equals half plus 1/3. Now if you simplify this, it will equal to 3 by 6 plus 2 by 6, and it will equal to 5 by 6. So this is the example. So LHS equals RHS, so the theorem is right. So that's for the video. Thanks for watching.